Hey everyone, this is Tom Kraz. Welcome back to my channel. Today we're taking a look into Docker and exploring its fantastic functionalities. So if you're keen to brush up on your Docker skills, then stay tuned. Docker is a popular platform that allows developers to automate the deployment, scaling, and management of applications within containers. But what are containers? Well, they're simply lightweight, standalone, and executable software packages that include everything to run a piece of software, including the operating system. Now let's take a look at the architecture for Docker. We can see in the diagram we have a client-server model where it says Docker host. Here is the Docker server. The client uses the Docker command via Docker run, Docker build, Docker pull, and uses REST APIs to connect to the Docker daemon, which in turn uses images to create and run containers. So what is an image? In simple terms, images are blueprints for Docker containers. They are lightweight, standalone, executable packages that include everything you need to run a piece of software. This includes code, runtime, libraries, environment variables, operating system, and configuration files. A Docker image serves as the basis for creating Docker containers. Think of it like this. Docker images are like recipes for baking a cake. They include all the ingredients, code, settings, software needed. When you want to bake or run your software, Docker uses this recipe or image to create a cake, which is a Docker container. This cake can be duplicated or run multiple times using the same recipe, ensuring consistency every time, no matter where you bake it. This means we can create a Docker container on any operating system and recreate that container on any other operating system. For example, we can build a container on a Linux system and then we can recreate that on a Mac or on a Windows server. So now let's take a look at installing Docker. Before we install Docker, it's a good idea to update the repositories so you get the latest version. After the repositories are updated, then we can just install Docker. Now we need to make sure that the user has the right permissions to run Docker. If we run the Docker command now, we get a permission denied. So we need to add the Docker group to our user. We can use the variable $user in capital letters to apply to the current user. Now, unfortunately, this still won't work. We need to log out and log back in again before this works. So I'm just going to pause now and just do a quick reboot. So now our server is rebooted. Let's just check that Docker is working for us now. As you can see, we have no containers running and we need to maybe do a demo. So let's pull down the most famous Hello World one and see how that works. Let's just explain this command first. So I'm using the Docker client to connect to the Docker server using REST APIs. I'm instructing the server to run a container. I'm telling it once the server is finished running the container to delete that container, otherwise it hangs around. And I'm telling it to use this image called Hello World. Now the Hello World image is up on the Docker Hub repository, but I have already downloaded this just to speed up our session. And let's just run it and see what happens. So let's just go through it quickly. So as you see here, it runs a Hello World image, creates a container, then from that container executes the generation of this text. If you do it yourself, you can read it, but you can see that the installation appears to be working correctly. So if you've made it this far, guys, well done. So in this session, we managed to download and install Docker. We configured our user so it could use Docker. We pulled down the hello world image and we created a container that spat out some text. Now I know this is very basic stuff when it comes to Docker, but if you've no experience with it at all, it's a really good starting point. Explore and enjoy the tool. My name is Tom Kras. Thank you very much for joining, and I will talk to you guys all later. Bye.